Imagine waking up tomorrow to find out that the AI you've been experimenting with has officially replaced you. Not because it's evil, not because it's conscious, but because, and this might sting, it simply tried harder than you did. While you were busy doom scrolling TikTok, arguing about pineapple pizza, or taking pictures of your matcha latte, AI was grinding 24/7, ingesting more information in a single day than you have in your entire life. And unlike you, it didn't complain once. You know how everyone is screaming about the AI boom? Bro, it's not a boom anymore. It's an extinction event for laziness. People are out here waiting for AI to calm down like it's a toddler having a tantrum. But here's the truth nobody wants to admit. AI isn't going to slow down to match your pace. You're going to have to speed up to match its pace. And if you don't, you're not just going to be replaced. You're going to be forgotten. Welcome to AI engineering, where the machines aren't the scary part. Your unwillingness to adapt is. Today, we're breaking down AI engineering, building applications with foundation models by Chip Huyen, a book that isn't here to pat your head and whisper sweet nothings about innovation. No. Chip Huyen is one of the few people in AI who has actually built real systems, scaled real products, and understands what happens after you finish playing around with ChatGPT prompts. Before she became one of the most respected voices in ML systems, Chip was teaching machine learning at Stanford, writing massively influential essays, consulting AI teams around the world, and, most importantly, building the kind of high-scale systems that keep entire companies alive. In other words, she's not another YouTube AI guru. She's the person those gurus copy. The book tackles a problem most people refuse to acknowledge. AI isn't magic, it's engineering. It's messy, expensive, unpredictable, and if you don't respect it, it will embarrass you. And before we go any deeper, let me slap on the mandatory disclaimer. This video is for educational purposes under the Fair Use Act, which means we're transforming the material with new insights, new framing, and, let's be honest, way more confrontation than the original book ever intended. If you want the full experience, buy the book and support the author. Now here's where the book hits you in the face. Chip isn't teaching you how to use AI. She's teaching you how to think like someone who builds AI, the kind of thinking that turns you from a passive consumer into an actual creator in this new era. You know those people who say, AI will take my job? Chip's book shows you exactly why some jobs deserve to be taken, because half the world is still treating AI like a toy instead of a tool. And if you're in that group, the book is basically an intervention. She explains how AI engineering became the fastest growing discipline on the planet. Not because AI is suddenly powerful, but because 99% of people aren't prepared for what powerful tools can actually do. This book isn't about hype. It's about reality, the economics, the engineering, the failures, the constraints, and the actual skills that will separate the people who ride the AI wave from the people who get crushed underneath it. Buckle up, because if the hook didn't insult you enough, the rest of this breakdown probably will. Welcome to Mindful Reads Hub. Let's get started. The dawn of machine intelligence, why the future now has a pulse. Every once in a lifetime, humanity meets something it didn't plan for. Fire, electricity, the internet, and now, intelligence we didn't birth in quite the way we build anything else. The moment where human intention collides with machine possibility is not far off. It's already happening. The book opens by declaring what many people are too busy Instagramming their latte to notice. AI engineering is not just another tech fad, it's a tectonic shift. Foundation models like GPT and Gemini didn't evolve naturally from the old world software ecosystem. They represent a wholesale rethinking of what software and intelligence even are. This is not an iteration of human-made software. It's an uprising of tools with agency. And if you don't understand that, you are already falling behind. Huyen argues very clearly that the acceleration of these models has outpaced our own ability to adapt. While the world is still arguing over whether AI is good or bad, foundation models have already become so powerful, so integrated, that we are building systems on top of them, not just around them. They're no longer just research curiosities, they are infrastructure. And that's a problem for people who still think building AI is about tweaking loss functions or collecting more data. They're missing the bigger picture. But what exactly is AI engineering? According to Huyen, it's not about training gigantic models from scratch. It's not about reinventing the wheel every time. Instead, it's about building applications on top of these pre-trained foundation models. The magic isn't in building a bigger dragon, it's in learning how to ride it. Engineers now must orchestrate around models whose behavior they don't fully control, designing systems where the model is a component, not the entire stack. This shift brings a new role for humans. Old school coders and data scientists wrote rules and fed examples. AI engineers design behavior. They don't just program, they shape emergent intelligence. That means humans are no longer just calculators. They become conductors, choreographers of machine thought. And that's terrifying for a lot of people, because along with the opportunity comes responsibility. When you're building systems on foundation models, you don't just choose algorithms, you choose what the intelligence becomes. You choose how to guide it, constrain it, or unleash it. The emotional reaction is real. Huyen doesn't sugarcoat the existential tension. People are excited, but also scared, because they know they're building something powerful, something with scale, and scale brings risk. And this isn't just a Silicon Valley thing, it's global. In China, open source foundation models are proliferating. In Europe, governments are scrambling with regulation. In developing nations, the question isn't just who controls AI, but who can even access it. The divide won't just be economic, it will be intellectual and geopolitical. You also need to grasp that engineering here isn't optional polish. Building with foundation models requires a completely different mindset, one where you design for uncertainty, where you decide whether to fine-tune or use APIs, where latency, cost, and user interaction are as important as raw capability. If you're still thinking like a traditional ML engineer, training from scratch, obsessing over every hyperparameter, you're building for yesterday's problems. And if you don't wake up to this shift, you're not going to ride the AI wave. You're going to get slammed by it. Key idea: the emergence of foundation models marks a fundamental shift in how intelligence is built, requiring a new discipline, AI engineering, where human purpose and machine possibility merge. Key takeaway: to survive and win in the new AI era, you have to stop tinkering with raw models and start building real systems, orchestrating voice, behavior, scale, and reliability. This is not a toy anymore, it's infrastructure. And unless you engineer intelligently, you will be replaced by someone who does. Favorite quote: AI engineering isn't about building more dragons, it's about learning how to ride the ones we already have. Giants beneath the surface, understanding the beasts we build on. Foundation models are the closest thing we've ever built to artificial instinct, and that's the part that freaks people out. Not because machines suddenly think, but because they behave in ways we didn't explicitly code. The old world of software was like IKEA furniture, a million steps, 2 missing screws, and if something broke, you knew exactly which human to blame. Foundation models aren't like that. They're more like raising a child on the entire internet than acting surprised when it has opinions. The truth is, these models aren't just programs, they're statistical machines that swallowed half the planet's text and came back speaking in patterns we barely understand. People treat them like pets, cute, helpful, predictable, but under the hood, they're closer to wild animals we've convinced ourselves we can leash. And here's the uncomfortable part Chip Huyen highlights. We build billion-dollar global systems on top of models whose internal workings we can describe, but not fully predict. Transformers process information by carving the world into attention patterns, spotting relationships we weren't observant enough or frankly smart enough to notice. Scale doesn't just make them bigger, it makes them behave differently. Emergent behaviors aren't glitches or miracles, they're the statistical equivalent of a personality forming. Countries across Asia, Europe, and Africa are scrambling to build their own versions because they know that whoever controls the models controls the future. Meanwhile, in the US, half the economy is either trying to ride the AI wave or pretending it's a bubble. Even as Nvidia reports record-breaking revenue and tech CEOs fire employees faster than they can lecture about AI-first restructuring. These models are reshaping industries before regulators even finish their morning coffee. But there's a darker point Huyen makes that people love ignoring. The intelligence we're amazed by is only as good as the data we fed it. And that data, it's messy, biased, incomplete, contradictory, like humanity itself. These models are mirrors, and if the reflection looks distorted, that's because we are. Bias doesn't magically disappear because you put it in a trillion parameter blender. Hallucinations aren't failures, they're the machine revealing the limits of its world model. You can't expect perfect truth from a system trained on human chaos, and yet people continuously treat benchmarks as holy scripture. It got 93% on MMLU. Great. And? A benchmark is a flashlight in a cave. Useful, but it won't tell you if there's a monster behind you. Benchmarks test memorization, not resilience. They tell you if a model works, not whether it's trustworthy, scalable, safe, or sane. Real AI engineering is about evaluation that happens in the messy real world, not in a lab, not in a leaderboard. Models don't care about your expectations, your deadlines, your product roadmap, or the fact that your startup only has 3 months of runway left. They behave according to the data they consumed and the math that guides them. And a lot of engineers still don't get this. They think debugging a transformer is like debugging a for loop. You can't patch your way out of emergent behavior. But here's the real punch in the face. You cannot build anything meaningful with these giants unless you understand what they actually are. Not the marketing version, not the AI will save us fantasy. The real thing, probabilistic beasts whose intelligence is borrowed from the world we fed them. And if you don't understand the giant you're standing on, the giant will step on you. Key idea: foundation models aren't software upgrades. They are massive statistical organisms shaped by scale, data, and emergent structure. To use them intelligently, you must understand their anatomy, their limits, and their contradictions. Key takeaway: you cannot safely or effectively build with foundation models unless you understand how they learn, how they break, and how they distort reality. Benchmarks won't save you, intuition won't guide you, and blind trust will destroy your product. Respect the giant or get crushed. Favorite quote: foundation models are trained with self-supervised learning on unlabeled datasets at scale. Truth, feedback, and failure. How to judge an intelligence. Most AI doesn't fail loudly, it fails silently, and that's the terrifying part. Humans, we fail with fireworks, screaming, excuses, broken deadlines, crying in HR offices. But AI collapses politely, quietly, invisibly. The system looks fine, the dashboards look fine, your CEO looks fine, until a user in Mumbai suddenly gets an answer so deranged it could have its own Netflix documentary. And the worst part, you don't even notice until the damage is already done. That's the world Chip Huyen forces you to confront. A world where intelligence doesn't break like software used to. It doesn't give you a red error box with a stack trace saying, "Hey dummy, fix this." Instead, foundation models produce confident nonsense, hallucinations wrapped in perfect grammar, delusions delivered with a smile, wrong answers wearing the costume of competence. This is why real AI engineering is less about building and more about interrogating. Because if you don't learn how to break your own system, the real world will do it for you, and the real world does not do gentle. This is where red teaming comes in. Not the corporate checkbox kind, the kind where you actively try to destroy your own product before the public does. In the book, Huyen makes it clear that red teaming is not optional, it's survival. Yet most teams treat it like flossing. They know they should do it, they pretend they do it, but they absolutely do not do it consistently. And because AI doesn't fail loudly, every untested edge case is a time bomb with a customer's name on it. Across continents, we're watching real examples of this. An African fintech startup rolled out an AI customer support bot that politely apologized for charging users for transactions they never made. A European hospital triage model quietly downgraded symptoms in older women because the training data underrepresented them. In the US, a major retailer got publicly dragged because its AI search suggested nonsense products based on hallucinated keywords. These aren't scandals, they're lessons. And the lesson is simple. Your model is only as robust as the edge cases you tried to break it with. Accuracy metrics alone, worthless. Accuracy doesn't tell you how the system behaves when stressed, cornered, confused, or emotionally manipulated by clever users. The exact scenarios where real damage happens. Huyen's point is blunt. Accuracy tells you what the model knows. Red teaming tells you what it will do. And then there's the truth problem. The book never pretends models believe anything. They don't. They generate the most statistically likely continuation of text. Truth to a model is just a pattern that appears frequently, which means hallucinations are not rare events. They're structural side effects of how the intelligence is assembled. Once you understand that, the idea of fixing hallucinations becomes a joke. You don't fix them. You design systems that can detect, constrain, or route around them. Around the world, companies are now building entire architectures just to contain the chaos. Retrieval systems, guardrails, multi-step reasoning checkers, fallback models, human escalation layers. These aren't luxury features, they're seatbelts. And if your AI system doesn't have them, you're basically throwing users into a self-driving car without brakes and hoping the marketing team can spin the crash. The book's most overlooked warning is about feedback loops. Not the cute kind where you learn from users, but the dangerous kind where user behavior reinforces the model's mistakes until the mistakes become the system. A single bad output can get picked up by your users, fed back into your dataset, and re-emerge in your model as truth. Intelligence, when poorly supervised, becomes self-poisoning. You don't need a catastrophic failure. 1,000 micro-failures will slowly rot your system from the inside. This is why Huyen argues that the architecture around the model matters more than the model itself. Evaluation is not a task. It's a lifestyle. Feedback isn't a feature, it's an immune system. Red teaming isn't a phase, it's a religion. And if you're not treating it that seriously, you're not doing AI engineering, you're gambling. And that, ironically, is why AI feels so magical and so dangerous at the same time. We're building systems that can reason across languages, industries, cultures, yet crumble silently when pushed just slightly outside their comfort zone. Models don't fail loudly, they fail silently. And silence is the most dangerous kind of failure there is. Key idea: real AI engineering is not about making a model accurate, it's about making the entire system resilient. Truth emerges from architecture, testing, feedback loops, and user-level evaluation, not from blind trust in a foundation model. Key takeaway: if you aren't red teaming aggressively, stress testing constantly, monitoring for hallucinations, and designing feedback loops that strengthen rather than corrupt the system, your AI product isn't reliable. It's a crisis waiting to happen. The world doesn't reward teams that build the smartest model. It rewards the teams that build the safest, most trustworthy one. Favorite quote, "Good evaluation is the foundation of reliable AI systems." Speaking machine, the ancient art of prompting and control. Machines don't think like us, but they listen. That's the part people keep pretending not to understand. They keep talking about AI like it's some unpredictable alien intelligence. Meanwhile, they're out here writing prompts like a 3 a.m. text to their ex and wondering why the model collapses into emotional nonsense. Wake up. These systems are literal probability engines, not your therapist. They don't get you. They don't vibe with you. They interpret patterns. And your pattern? Usually chaos. The reality is this. Words have become a form of code. You're not typing, you're programming. Every prompt is a lever, a steering wheel, a psychological nudge for a machine that doesn't have feelings but acts like it understands them because statistically, it knows how humans respond. Chip Huyen is brutally clear about this in her breakdown of prompts. Their instructions, examples, constraints, formats, context windows, all stitched into one messy bundle where clarity is the only real power you have. But people treat prompts like magic spells. They'll type, "Write me an app," and then scream at the screen when it hallucinates. That's not the model failing. That's you sending a drunk voicemail to an emotionally detached alien and expecting Shakespeare. If you want a model to behave, you don't beg, you design. You choose the tone, the role, the structure, the order, the constraints. And here's the part most people hate hearing. If the output sucks, the prompt usually sucked first. That's why prompt engineering became a job. Not because it's complicated, but because humans are spectacularly bad at giving clear instructions. Try asking your coworker for a simple file and watch the chaos unfold. Now imagine giving ambiguous instructions to something running on billions of parameters and hoping for the best, but prompting alone won't save you, because the moment your prompt touches real-world information, the ground shakes. Models hallucinate when they lack context, not because they're broken, but because they're guessing. So the world invented RAG, retrieval-augmented generation, the AI equivalent of giving the model receipts so it stops lying so confidently. Chip explains how this external memory layer pulls from databases, documents, and past conversations so the model can stop inventing nonsense and actually respond with grounded facts. Think of it like giving your friend Google before asking them a question. Suddenly the answers improve. Meanwhile, agents are what happens when we let models not just read the world, but act on it. Tool usage, planning, browsing, executing. And here's the catch. Autonomy isn't an accident, it's a design choice. If your AI suddenly starts doing more than you asked for, that's not the model being smart, that's you failing to set boundaries. And yes, boundaries exist in prompts too. Without them, the model will improvise, and improvisation is just structured hallucination. People in the US, India, China, Europe, everywhere are discovering this the hard way. The moment they let an AI agent run wild in their workflow, it either becomes a productivity superpower or an automated disaster generator. There's no middle ground. The global economy is already reacting to this. Productivity forecasts are rising while labor markets panic because one well-designed agent can replace entire task pipelines. Not whole jobs, pipelines. The difference between those who benefit and those who suffer comes down to who learns to speak to the machine and who keeps treating it like a magic trick. And don't get too smug if you think you're safe because you understand prompts. Overprompting is the new overeating. People cram 200-line system messages into a model and then wonder why it collapses under its own logic. Prompts aren't meant to be novels, and fragility is real. Change one word and the model flips personalities. That's why Chip Huyen keeps repeating the point. Prompting is an engineering discipline, not a creative tantrum. You know when to stop prompting and start designing actual infrastructure, context pipelines, evaluation loops, retrieval layers, constraints, formatting logic, because prompting alone can only take you so far. In other words, the machine listens, but it listens like a lawyer, literally, pedantically, and without emotional context. If you can't speak its language, it's not the machine that's unprepared for the future, it's you. Key idea: language is now an interface. Prompting, retrieval, and agent design are the real tools for controlling intelligence, not wishful thinking or vague instructions. Key takeaway: a model is only as useful as the instructions, context, and guardrails you give it. If you don't learn how to communicate with machine logic, structurally, clearly, and intentionally, you will get automated chaos instead of automated leverage. Favorite quote: the problem is not with prompt engineering. The problem is when prompt engineering is the only thing people know. Shaping intelligence, from raw models to purpose-built minds. Every great intelligence is sculpted, never born. People love pretending models just emerge, as if they crawl out of some digital womb ready to deliver miracles. No, that's not how this works. Raw models are toddlers with protein powder, potential without purpose, and purpose doesn't appear. It's engineered, sculpted, chiseled through choices that most people never see and even fewer understand. Everyone wants AI superpowers, but nobody wants to do the quiet, unglamorous work of shaping the mind behind the magic. Fine-tuning is where the myth of AI genius meets the ugly truth of responsibility. You take a general purpose model, a huge, well-read, easily distracted, occasionally delusional overachiever, and force it to focus. And depending on your approach, you're either guiding it or wrecking it. Chip Huyen breaks this down with surgical clarity. Full fine-tuning, LoRA, instruction tuning, preference modeling, each one a different level of sculpting pressure you apply to the model, each one with different risks and different costs, computationally, financially, and ethically. But here's the part people never admit. Half the world is using fine-tuning as a band-aid for bad engineering. They don't want to fix the data. They don't want to fix retrieval. They don't want to fix architecture. They just want a magic switch labeled "please behave." And when the model hallucinates, they blame the model instead of the amateur who shoved thousands of mislabeled training samples into it like expired groceries. Across India, Nigeria, Brazil, the Philippines, countries exploding with new AI startups. People are learning the same lesson the US and China already learned the hard way. The fastest way to destroy a model is to fine-tune it on garbage. Data curation isn't optional, it's the entire ballgame. Chip calls this out directly. Datasets aren't collections of facts, they're belief systems. They encode tone, style, priorities, morals, biases, and blind spots. Every dataset teaches the model how to see the world, so if you feed it contradictions, toxicity, sloppy patterns, or inconsistent labeling, don't be surprised when it starts behaving like a confused philosopher trapped in a funhouse mirror. And then there's data poisoning, which is becoming the AI version of graffiti. Hackers inject corrupted samples into public datasets. Competitors load subtle misdirections into benchmark corpora, and even unintentional contamination can mutate a model's behavior. This isn't sci-fi. This is happening right now. Governments from the EU to Singapore are scrambling to build regulatory guardrails because they finally realized something engineers already knew. One poisoned dataset can create a generation of broken models. But let's not pretend that engineers are innocent either. Some teams intentionally fine-tune models to make them overly compliant, so they agree with anything, fact or fiction. Others tune them to be hyper-confident, because confident answers impress investors, and some optimize purely for speed, even when it means sacrificing nuance or safety. The ethical risk isn't theoretical, it's structural. When you sculpt intelligence, you choose what it learns to value. You decide what it ignores. You define which mistakes it is allowed to make. And yes, fine-tuning can work miracles. LoRA layers can teach a model to write legal briefs in a specific country's dialect without retraining billions of parameters. Instruction tuning can make a model infinitely more cooperative. A carefully crafted dataset can give it a personality, calm, direct, humorous, analytical. But the moment you begin sculpting an intelligence, you inherit the responsibility of the sculptor. And sculptors throughout history have always had to answer the same question: what exactly are you trying to create? Because if you don't know, the model will decide for you, and you probably won't like its answer. The global economy is watching all of this unfold with the tension of people staring at an earthquake fault line. Tech companies want specialization, governments want control, consumers want magic, and the engineers? They're stuck in the middle, quietly shaping the minds that will shape the next century. The future isn't built by people who understand AI. It's built by the people who understand how to refine it, how to mold it into something trustworthy, directional, and aligned with outcomes instead of accidents. You can sculpt brilliance, or you can sculpt disaster. But either way, you are sculpting something with consequences far beyond yourself. Key idea: specialized intelligence isn't discovered, it's engineered. Fine-tuning, dataset design, and ethical boundaries determine what a model becomes, not its raw size or hype. Key takeaway: every dataset, every tuning step, every constraint is a chisel stroke shaping the model's identity. If you don't control what you're teaching the model will inherit chaos and amplify it at scale. Favorite quote: datasets are belief systems, so choose what you want your model to believe carefully. Faster than thought, optimizing machines for the real world. The fastest intelligence wins, always. That's the law now. Not the strongest, not the smartest, not the most beautifully fine-tuned by an engineer who listens to lo-fi and pretends they're in a montage. Speed is the currency of intelligence. And if you don't believe that, watch what happens the moment your AI app takes longer than 2 seconds to respond. Users evaporate like you just turned on the lights at a nightclub. That's the brutal economy of attention. If your model thinks too slowly, it might as well not think at all. The world figured this out fast. In the US, e-commerce companies started ripping out old recommendation engines because a half-second delay cost them millions in abandoned carts. Meanwhile, in India and Indonesia, entire micro-businesses run on WhatsApp automation collapse when latency spikes. And in China, companies won't even consider deploying a model unless it can serve millions of requests with sub 200 milliseconds response time. This isn't preference, this is survival. And here's where Chip Huyen is uncomfortably honest. Most engineers underestimate how brutally slow models are until they're forced into production. Academic benchmarks lie, prototypes lie, even your laptop lies. Only real-world traffic tells the truth, and that truth is merciless. Production isn't where AI goes to shine, it's where AI goes to be humbled. You thought you had a genius, put it in front of 20,000 users and watch it crumble into a stuttering mess. So what do? We optimize. Quantization becomes the first weapon, shrinking models down from their bloated GPU hogging form into something that actually responds before your user dies of old age. Distillation turns giant models into smaller apprentices that mimic their teacher's intelligence without stealing all your compute. Caching eliminates repeated work, because if 1,000 users ask the same question, your model shouldn't have to rediscover fire every single time. And batching, batching, the thing engineers pretend they understand until they realize managing concurrent requests is like juggling knives covered in oil. If you're lucky, your hardware cooperates. If you're unlucky, you're stuck on CPUs, wondering why your model behaves like it's commuting through Los Angeles traffic. GPUs help, until you realize they're expensive, scarce, and prone to bottlenecks you didn't even know existed. Accelerators, great, if you're a trillion-dollar company or a sovereign nation state. The rest of us are playing Tetris with compute budgets while users demand instant answers. But scaling isn't just speed, it's fragility. It's load spikes that appear out of nowhere. It's versioning hell. It's monitoring systems that alert you at 2 a.m. because your GPU memory exploded like a watermelon under a hydraulic press. Chip explains this clearly. Prototypes die the moment they meet reality because nobody designed them for the ugly parts. The failing APIs, the corrupted inputs, the runaway queues, the traffic patterns that never match your optimistic projections. Production is the graveyard of unprepared AI dreams. And then there's latency, the silent killer of every promising AI startup. Nobody cares if your answers are brilliant if they arrive too late to matter. Users today have the patience of a caffeinated squirrel. Even banks are discovering that AI customer service tools get abandoned if they pause too long between responses. In Kenya's mobile banking ecosystem, shaving off 300 milliseconds boosts usage by double-digit percentages. In South Korea, telecom companies won't even approve AI call center agents unless they match human response timing. Speed isn't a feature, it's credibility. But here's the twist the world didn't see coming. The future isn't bigger models, it's smaller ones, optimized, distilled, locally run, privacy-preserving, battery-efficient little beasts that live on your devices instead of in distant data centers. Chip's prediction is simple and terrifyingly logical. The next wave of AI is personal, fast, and distributed. Local-first AI doesn't wait for servers. It thinks where you are, it works offline, it responds instantly. And when that happens, the entire hierarchy of AI power shifts. The companies who win won't be the ones with the biggest models. It'll be the ones with the fastest ones. Tomorrow's AI doesn't need to be a genius. It just needs to be quicker than the one next to it. And if you're not optimizing for speed, aggressively, obsessively, ruthlessly, you're not building intelligence. You're building an anchor. Key idea, speed is the real competitive advantage in AI. Optimization techniques, quantization, distillation, caching, batching, and hardware strategy determine whether an intelligent system survives contact with the real world. Key takeaway, raw intelligence is worthless if it can't respond fast enough. The future belongs to optimized, efficient, locally capable systems that can scale without collapsing under real-world pressure. Favorite quote, optimizing inference is often more impactful than improving model quality because slow intelligence is indistinguishable from no intelligence. Conclusion. Everything you just heard, every cold open, every punchline, every uncomfortable truth has been pointing to one thing. The age of guessing is over. The age of pretending you get AI because you tried ChatGPT twice is dead. The age of hiding behind excuses, behind fear, behind technology is moving too fast is over. Because the future isn't waiting for anyone, and it definitely isn't slowing down so you can catch your breath. We started with the moment the world changed, when machine intelligence stopped being a toy and became a force with agency. Then we dove beneath the surface into the dark lungs of foundation models, where data, bias, and raw scale collide to create something terrifying and miraculous. We learned how intelligence lies, how it breaks, how it fails silently while humans trust loudly. And we exposed that the real skill isn't building models, it's judging them, tearing them apart before the world does. We spoke the language of machines, the psychology of prompts, the logic of structure, the illusion of control, and the uncomfortable truth that most people write prompts the same way they make life decisions, chaotically. We sculpted intelligence not by dreaming but by engineering, fine-tuning, shaping datasets, choosing what a model believes, and wrestling with the ethical weight of teaching a machine how to behave. And then we confronted the final battlefield: speed. Real speed. The kind that separates winners from fossils. The companies, creators, nations, and human beings who harness optimized intelligence will rewrite entire industries, while everyone else argues on the internet about whether AI is good or bad. Spoiler, the universe doesn't care. All 10 chapters, all the tension, all the warnings, all the instructions were pointing to one hauntingly simple truth. The future doesn't reward understanding, it rewards building. People will talk forever about how AI is dangerous or promising or disruptive or whatever headline lets them feel smart for 5 seconds. Meanwhile, somewhere in a garage in Lagos, or a co-working space in Sao Paulo, or a dorm room in Manila, someone is using these exact ideas to build the next system that will put half of today's AI experts out of business. Because the world is shifting from knowing about intelligence to shaping intelligence, from using AI to orchestrating it, from asking, what will AI do to us, to asking, what can we do with this power if we stop being afraid of it? And this is where every viewer has to make a decision that will echo through their career, their finances, and their identity. Are you going to be the person who watches the future happen, or the person who builds it? There is no middle category anymore, not in this era. If you take nothing else from this entire journey, take this. Intelligence is no longer a human monopoly. The new advantage is the human who knows how to direct it. You can stay scared. You can stay skeptical. You can keep waiting for governments, influencers, or tech CEOs to figure it out for you. But understand this, the future won't slow down for you, doesn't care about your comfort zone, and definitely isn't waiting for your permission. So learn the craft, master the tools, build something that forces the world to pay attention, because the only thing worse than a future shaped by AI is a future shaped by people who were too afraid to learn how AI works. If this breakdown hit you harder than you expected, good. It means you're awake now. It means you understand what few people are willing to accept. The world is being rebuilt by those who learn fastest, not those who wait longest. And if you want to go deeper, if you want the full blueprint, the context, the nuance, the hidden insights this summary couldn't fit, then don't just walk, run to get Chip Huyen's book, AI Engineering. It's not just worth reading, it's worth studying. The kind of book you keep on your desk, not your shelf. Go buy it, support the author. Don't be the person who only watches summaries and pretends they read. Be the person who actually does the work. And remember this final message, the one I want carved into your brain long after this video ends. The future doesn't belong to the people who fear intelligent machines. It belongs to the people brave enough to build with them. Now go build.